Oh, this is the final project for the Managing Machine Learning project course at Duke University by Coursera. So we'll just jump right into it. Essentially, the problem statement, there's a variety of different things that have to be satisfied. So I've actually laid that out in these slides. Uh, the very first thing is the problem statement. So the problem statement is we're trying to proactively predict additional diseases or problems based upon a review of the patient's electronic medical records. Based upon the requirements listed as the final project, there's a variety of different things that we have to evaluate, right? So first of all, is there a problem? Yes, there's a problem. As proactive prediction of disease is not something that happens consistently for a variety of different reasons. That could include lack of time on the provider's part, including lack of patient-provider follow-up. It can include the patient just not having resources, a variety of different resources as far as cost, travel, and the like. Does someone care? Absolutely. Proactive management of patient diseases results in a decrease. We know it results in a decrease in medical care costs, and also leads to a better patient quality of life. Can ML solve this? Yes. I believe that it can, with the huge amount of data that is now available within a variety of different electronic medical records, including Epic, Athena, eClinicalWorks, Oracle, and there's others as well. These are just some of the vendors that actually have these systems that has these records. And I can imagine that ML algorithms should be able to predict diseases or problems that should be proactively managed so that it doesn't become a larger problem based upon the data that is already present in these systems for these, within these vendor systems, and the vendors themselves can potentially implement these machine learning algorithms. So that's a problem and the why it's attractive. Moving on, essentially define the problem a little more. The target user that we are targeting in this particular instance are primary care providers. And that can include anyone that authorizes prescriptions and follow-up in care. So it's not just your, primary care medical doctor. It could be a DL or also a medical doctor, a nurse practitioner, and a physician's assistant, or just some of the types of primary care providers that can actually be a target for this particular, this particular use case that we were examining around leveraging machine learning. The problem essentially is, there's not a lot of time or resources. Anybody who's actually gone into, for a routine medical issue knows that the providers in a variety of instances usually only have a very limited amount of time. They have a full schedule of patients that they have to see, and typically in the state in which I live, that time period is about 15 minutes and not any longer than that. So because of this lack of time and resources, disease prevention is usually not a priority. They're usually trying to focus on the problem at hand, right? In other words, why are you here? And then they try to just focus on that particular issue. So the advent of this type of machine learning technology and readily available information from the data that we have, providers should be able to be made aware of the potential issues that would result in an appropriate follow-up, in plan of care. So there could be certain things that are underlying that the provider just hasn't had a chance to review the patient's chart prior to the visit, and having this stuff in the EMR, which we'll talk about in a few minutes, is very valuable information. Why it matters is obviously it matters. We've already talked about that proactive management, prevention of disease leads to a better quality of life as well as lower medical costs, in addition to even elongating a patient's lifespan because they're proactively managing the problem as opposed to managing it when it becomes an actual issue. In the current state, and I talked about this a little bit, above, there really isn't a lot of time because of the extremely short visits, and the provider really doesn't have the time to focus on what's the problem at hand. And even, if we assume that they can take care of that in the next annual visit, a lot of times, a lot of patients don't come, don't have annual exams. And so in the instances where they don't have annual exams, they only go to the patient, the patient only goes in to see the doctor when it's absolutely needed. It becomes even more critical for that scenario for the doctor to say, hey, here's a problem that I'm seeing that we may want to follow up on. So that is a problem. Success for me is defined as the primary care providers being able to see a list of potential problems and issues that require follow-up, and the actual patient is followed up. And so from an output and outcome, outcome and output perspective, some outcomes could be number of disease and problems listed where the provider successfully follows up with a patient. And that indicates that in the EMR, we'll talk about the integration into the EMR UI in a minute, and then increase in satisfaction for providers via maybe survey results as a result of proactively managing disease. I typically get surveys. I'm sure other people get surveys as well. So that's maybe another outcome that that we can leverage. As far as output, number of diseases, the problems predicted, as well as the rate of accuracy of the model predictions, are some of the outputs that I can imagine that we can leverage in this particular scenario. The solution is something that I've talked about earlier as well, right? So there is a lot of data that these EMRs already have. I can imagine, in addition to maybe doing some additional user interviews and gathering some more data that way, a review of the EMR's data, and then doing some simple regression classification techniques to reveal some of the features that may be needed that can result in maybe some more accurate model predictions would be the way to go. The model selection, again, would be based upon the analysis. We can determine what model to use, whether it's a simple linear regression, maybe decision tree that would would be best in a particular scenario. Today, again, providers, nurses and doctors are doing this through a variety of different question and answers. And then finally, the decision process flow from the model. And this is something that is interesting, is that the model is not something that is visible to the end user. It is really something that is running behind the scenes in an EMR. The way I imagine it would be running behind the scenes in an EMR, and the way it would manifest, the results would manifest themselves would be through the UI of the EMR in a separate screen, or maybe even integrated into the provider's workflow, where they can say, hey, here's the list of problems that are potential problems for this particular patient, require follow-up. It could be a separate screen. It could be part of their workflow. It could be part of the screen that they're currently in. There's a variety of different ways we can design the system. And of course, prototyping would reveal UI type prototyping, design prototyping would reveal the best instance or the best UI to go with in production. So, but those are just some of the options. As far as solution validation, I foresee, and some of the stuff that they taught in the course, the initial round would be just based feedback. You could use a simple Excel spreadsheet, use a subset of the data, and then the model would be just a mock-up. And then in round 2, you can do refinement prototyping using training data sets. And then what I essentially see is in the production version, having that UI integrated into the EMI with a full set of data running in production, and that would be the way to validate the solution and get to a model that is working and workable. Some of the design decisions that need to be taken into consideration is cloud versus edge. I went with cloud solutions because latency is not really a concern. The model can be running offline to provide predictions that are readily input into the patient's chart, right? There is no need for us to do online, real-time type of predictions. And that leads into the next one, which is online versus offline. Predictions don't need to be in real time, can be handled in batch mode, maybe on a nightly basis or maybe off peak hours, and input into the patient's chart so that, that are seen, patients that are seen on a particular day. So the model doesn't have to run on the entire data set. Maybe it could be a lot more targeted and run on maybe just the patient population that is being seen for that day. And then online versus offline, again, talked about this earlier, but offline learning would be best, for the reasons that I've already mentioned above. It doesn't need to be online. It doesn't need to be real time. It can absolutely be, there's a latency concern. It could absolutely be something that is running offline and behind the scenes, and then providing those predictions. What are some of the risks? So some of the risks that I foresee in this solution are with the data. Some of the data, for example, may be inaccurate or incomplete, such as family history. When a patient is filling in a questionnaire, sometimes information is left blank, sometimes it's inaccurate, sometimes illegible, and so that data could be missing. That can provide some inaccurate predictions or even failure of the model in certain instances. So this information is critical for us to actually have in order to provide accurate recommendations, where we would have to follow up with the patient in order to get that information, in order to put that stuff into the model. And if in case that doesn't work, Perhaps it's a matter of, working with cleaner data and being able to actually look at that data and say, where are certain things that make sense that we can actually take out that may not work in the model, may cause the model to fail. Another thing that I see is model decay. Maybe it's best to actually have triggered retraining of the model because it's likely to decay over time with training patient population data. The best way to do so would be to examine the model performance in terms of actual versus predicted output. If the output goes below a particular threshold, it should be a signal to retrain the model based upon changes in the environment, changes of the data. And then another thing that I see in production happening may be that the bias that is introduced in the data. So it's possible that the underlying bias in data being examined it's possible that the new bias in the data are being examined, such as maybe a certain demographic in the population that is more likely to smoke. Maybe that we only have data in a particular demographic, and then that data indicates that the particular population subset of the population always smokes. So during model updates, there should be a mechanism for us to penalize such biases so that it provides more accurate predictions from the model. Anyway, this is my project. Thank you so much for reviewing, and I hope you have a great day. Thank you.